All right, we're going to graph two more equations where f of x is x squared, and like the last video, I'm just going to go ahead and graph it the way we know it's supposed to be graphed. You may have to look back at that video if you don't know that. And then I'm going to graph h of x where it is a fraction. A is a fraction and it's negative to show you what's happening there. All right, so the parent graph f of x equals x squared. Remember that their vertex is at 0, 0. I'm going to go right one and up one and left one and up one to put a point. Then I'm going to go right one and up 3 and left one and up 3. And there's the very fast way of making the parent graph of f of x equals x squared. All right. Now, if the a is not 1, then I'm going to have to do some algebra with it. I'm going to notice that the a is 1/3 and it's negative. That's going to tell me right quick that the parabola is going to be upside down. That negative will be upside down. And it's also going to tell me that it's going to be opened wider because this 1/3 is a fraction between 0 and 1. So let's go ahead and do the algebra. I have negative 1/3 times negative 6 squared. Well, negative 6 squared is 36. And that just means you've got to divide 36 by negative 3. Multiplying by 1/3 is the same thing as dividing by 3. So 36 divided by negative 3 would be negative 12. So I'll have a point at negative 6, negative 12. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think I didn't lose it. I hope I didn't. And then let's do negative 1/3 times 3 squared. Now the reason that my domain is negative 6, negative 3, 0, 3, 6 this time instead of negative 2, negative 1, 0, 1, 2 is because I need things that I know I'm going to divide 3 by 3 into, and these are factors of 3. So that's going to make me not have to deal with fractions. So that's very helpful there. So 3 squared is 9, and 9 divided by negative 3 is negative 3. So I have a point at negative 3, negative 3. So left 3, down 3. There's a point there. All right, we know it's symmetric, so there should be one on the opposite side of this as well. So we have negative 1/3 times 0 squared. 0 times anything is 0, so I have the ordered pair 0, 0. Vertex is not moved, it's in the same place. And then watch what happens. Negative 1/3 times 3 squared. 3 squared is 9. 9 divided by negative 3 is negative 3 again. So a 3, right 3, down 3, 2, 3. There's that symmetry there. And of course, we'll expect one the same distance from this axis of symmetry on the other side, and it comes from this one. Negative 3 times 6 squared. So 36 divided by negative 3 is the negative 12 again. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, notice this parabola opening wider than the original parent graph and being upside down. All right, so the second one opens down. The first one opened up. So the parent one was up. H of x was down. The vertex on both of these were at 0, 0. I didn't write down axis of symmetry. I should have. The axis of symmetry on both of them is that middle point where x equals 0. It is a vertical shrink factor 1/3 because a is a proper fraction. And then it's a reflection in the x-axis because a is negative. If it asks you the domain on both of them are all real numbers. The range on the top one is y is greater than or equal to 0, and on the bottom one, y is less than or equal to 0.